Hi friends, once again welcome back in our educational channel, that is Milinda's Ideas. Friends, in today's video lecture we are going to study the next type of multiplexer, that is 4:1 mux. So in 4:1 mux there are 4 input and 1 output, and the simple multiplexing action is obtained by using a rotary switch. So in this case we have to use single pole 4-way switch, SP 4-way switch is used, and the input signals are connected to that way, single pole 4-way. So 4 ways are used to connect the input terminal, input signals, that is I0, I1, I2 and I3. These are the inputs and Y is the output. But in actual, in digital circuit, this rotary switch may not be used because it is manually operated. So the time required to connect the input signal to the output terminals may be very high. We require more time. So in digital circuits we have to use in digital circuit or in digital instrument we have to use a logic circuit. We have to use basic gate to construct the logic circuit, that is 4:1 mux. So friends, as there are 4 inputs, minimum 2 control lines are required because the formula is 2m is equal to n. So as there are 4 inputs, that is n is equal to 4, so m is equal to 2, that is 4. So 2 control lines are required, and in this circuit as there are 4 inputs, the 4 AND gates are required and one 4-bit OR gate is required. The output of that AND gates, that is first, second, third and fourth, the 4 AND gates are used. The output of that AND gates are connected to the OR gate, which gives a single output, and that is basically output of multiplexer. So now in front of you the circuit diagram, that is the logic diagram of multiplexer, is going to be displayed. There are 4 AND gates, 4 inputs are there, 1 output is there. So 2 control inputs or 2 select inputs are required. The first input, the input connected to first AND gates are I0, that means I0 or D0, D means data, I for input. So I0 and the 2 control inputs, in this case the output of NOT gates, that is S0 complement and S1 complements are connected to the first AND gate. So the input for first AND gates are I0, S1 complement, S0 complement. The input for second AND gates are I1, S1 complement and S0. The input for third AND gate are I2, S1, S0 complement, and the input for the last AND gate are I3, S1 and S0. So what is the output of first AND gate? That is I0, S1 complement, S0 complement. The output of second AND gate is I1, S1 complement, S0. The output of third AND gate is I2, S1, S0 complement, and output of fourth AND gate is I3, S1 and S0. So these are the output of the particular AND gates, and these outputs are connected to the OR gate, whose output is Y is equal to I3, Y is equal to I0, S1 complement, S0 complement, plus I2, S1 complement, S0, plus I2, S1, S0 complement, plus I3, S1, S0. आपण परत रिपीट करूया. The output of OR gate is Y is equal to I0, S1 complement, S0 complement, plus I1, S1 complement, S0, plus I2, S1, S0 complement, plus I3, S1, S0, and that is the output of our multiplexer. So that is a circuit diagram, that is a logic diagram of 4:1 mux. So now we are moving towards the working. So first case, what is the first case? The first case is S is equal to 0, Y is equal to 0. मग S1 is equal to S1 is equal to 0, S0 is equal to 0. So this is the first case. So in this case, the first AND gate becomes enable. Why it becomes enable? Because as S1 and S0 are 0, the select terminus or control terminus connected to the AND gates are the complement of this input. कारण इनपुट काय म्हटलेलं आपण, इनपुट फॉर फर्स्ट AND gate is I0, S1 complement, S0 complement. So the complement of 0 0 is 1. So the control input of first AND gate becomes high. So the first AND gate is in enable mode, and hence the data connected to this AND gate, that is I0, that is D0, is selected and fed to the output terminal. That is first case. First case काय म्हटले आपण, that is when S1 is equal to S0 is equal to 0, Y is equal to I0. Y is equal to I0. Second case. In second case, that is S1 is equal to 0, S0 is equal to 1. So as per the connections, that is control inputs connected to the AND gates, the second AND gate becomes enable because its control inputs, both control inputs are high. So obviously this gate, the second AND gate is in enable mode, and data connected to this gate, that is I1, is now selected and fed to the output terminal. So in this case, Y is equal to I1. Means in this case, that is when S1 is equal to 0, S0 is equal to 1, Y is equal to I1. That is second case. Now third case, that is when when S1 is equal to 1, S0 is equal to 0. When S1 is equal to 1, S0 is equal to 0, the third AND gate is in enable because the control input connected to this gate becomes high. त्याचे control input high झाले, so that third gate is in enable mode, and data connected to this gate, that is I2, is now connected to the output terminal of OR gate. So friends, in this case, that is when S1 is equal to 1, S0 is equal to 0, Y is equal to I2. Now the last case. What is the last case? That is when S1 is equal to S0 is equal to 1. That means both control inputs are high. The fourth AND gate becomes enable, and in this case, all other AND gates are in disable mode. So as the fourth AND gate becomes enable, the data connected to the fourth AND gate, that is now I3, is selected, and that data is connected to the output terminal. So in this case, friends, when S1 is equal to S0 is equal to 1, Y is equal to I3. That means as per the control inputs, from this we can conclude that as per the control input, that is 0 0 0 1 1 0 or 1 1, as per this control input, one of the data is selected and fed to the output terminal. So that is 4:1 mux. Now in front of you, the symbol of that 4:1 mux is going to be display. So display झाला पाठीमागे आपल्या. As there are 4 inputs, I0, I1, I2, I3, ते आपण mention केलेत. As there are 4 inputs, the 2 control lines are required, 2 select lines are required. The 2 select lines are displayed, that is S1 and S0 are the select lines, and Y is the output, and it is a 4:1 mux. Now what is the truth table? The truth table of this gate, as there are 2 inputs, S1 and S0, and output Y. The first, when both inputs are low, that is S1 is equal to S0 is equal to 0, Y is equal to I0. That means I0 data is selected and connected to the output. When S1 is equal to 0, S0 is equal to 1, Y is equal to I1. When S1 is equal to 1, S0 is equal to 0, Y is equal to I2, and when both S1 and S0 are high, output Y is equal to I3. So friends, that is 4:1 mux. So once again, thanks for watching this video channel. Thanks for watching this video lecture. In next video lecture, we are going to study the multiplexing ICs. Actually काय करतो आपण, हे आपले लॉजिक सर्किट्स आहेत. मग इथं काय वापरलं आपण, इन लॉजिक सर्किट्स we have to use basic gates. But in actual digital circuit, we have to use the ICs. आपण गेट्स नाही वापरणार, आपण त्या गेट्सचं कॉम्बिनेशन असलेले ICs यूज करतो. आणि त्या IC वापरून काय करतो आपण लॉजिक सर्किट डिझाईन करतो. सो इन नेक्स्ट व्हिडिओ लेक्चर वी आर गोइंग टू स्टडी द व्हेरियस टाइप्स ऑफ लॉजिक ICs used as a multiplexer. So friends, once again thanks for watching this video lecture. Bye, take care, see you again.